In this video, we're going to look at alcohols and phenols. We'll look at their structure, talk about properties, and look at how to name and draw them. First off, alcohols and phenols both contain the hydroxyl group. So that is what defines them as being part of the alcohol and phenol. So the hydroxyl group is an oxygen bonded to a hydrogen, this right here. In an alcohol, that hydroxyl group is bonding to an alkyl group. We can write that in organic chemistry as an R group, which just simply stands for an alkyl group, some carbon-containing group. So you have a carbon bonding to a hydroxyl group here. An example would be CH3OH. This is an alcohol. How that would be written out, showing all of the bonds, would be like this. Here's the expanded form of that, where you have an oxygen bonding to a hydrogen. So remember, carbon makes 4 bonds, so it's bonding to 3 hydrogens in this example, 1 oxygen, and then that oxygen makes 2 bonds, and so it's going to bond to the hydrogen. A phenol is an alcohol where that hydroxyl group is bonding to a benzene ring, and so that's named as a phenol. Hydroxyl groups, that OH group is a polar group, and so it can form hydrogen bonds with water. Therefore, small alcohols are soluble in water. Generally, alcohols with 4 carbons or less are going to be soluble in water. Let's look at naming alcohols. This first one has 1 carbon bonded to the hydroxyl group. We're naming them based off of the same system that we have before. The alkane name for 1 carbon would be methane. For naming the alcohol, we're going to drop the E in methane and add an OL ending. So it becomes methanol with that OL ending. But that first part, the methane part or the meth part, tells us that it is 1 carbon. The OL tells us it's an alcohol. So that 1 carbon is bonding to a hydroxyl group. In the second example, I just wrote this molecule, you might say backwards, but it doesn't really matter which way you write it. But I did write the hydroxyl group on the left side just to show you that sometimes you might see it written over there. And in this case, the hydrogen is written first before the oxygen, but it's still an OH, oxygen, hydrogen bonding to that carbon group there. In this molecule here, we have 2 carbon atoms, so that would make it an ethanol. Okay, coming down to the third one down here, I'm going to number the carbons. So there's carbon 1, carbon 2, carbon 3. So if this has 3 carbons and that hydroxyl group is coming off of that first carbon, but it would be propanol. And starting with 3 carbons, because you have more than one location where that hydroxyl group could be located, you have to number where it is. So this is 1 propanol, where that hydroxyl group is coming off of the first carbon in our molecule. So down the last one here, I'm going to number it 1, 2, 3. This is propanol as well, but in this case, the hydroxyl group is off of the second carbon in our chain, and so we would name it as 2-propanol. So in alcohols, that number in the front tells you which carbon in your chain the hydroxyl group is off of. Okay, here's a bit more of a complex looking alcohol, but if we just take it step by step, we'll see that naming is very similar to what we've done before. The first step is always to find the longest carbon chain. And the longest carbon chain for this molecule, I'm going to circle it, is this right here. And when you number it, you want to start on the end of the carbon chain that is closest to your functional group, to your hydroxyl group. And so I will start on my left over here. This is carbon 1, 2, 3, 4, 5, 6, 7, 8. So 8 carbons, and it is an alcohol, and that hydroxyl group is off of the second carbon. So that is a 2-octanol. All right, let's name our other substituents. We have a methyl group coming off of the 4th carbon and a methyl group coming off of the 5th carbon. And so those are going to be 4, 5 dash dimethyl 2-octanol. And that's how to name it. Basically, same as we've done before. Okay, here we have an example of drawing 2-chloro-3-pentanol. And again, drawing is much the same as you've done before. Start with the last part. Pent tells us that there are 5 carbons. We have our OL ending telling us it's an alcohol, and that alcohol, that hydroxyl group, is going to be off of the 3rd carbon. So I will start with just drawing out 5 carbons. 3, 4, 5. And I'll just start numbering on my left. So that means my 3rd carbon would be here, and it gets an OH group. Then working backwards from our name, we have a 2-chloro. So off of this 2nd carbon, I have a chlorine. Okay, now that all that's left is to add the hydrogens. I'm just going to add the bonds, or our hydrogens understood at the end of those. So that would be the expanded structural formula for that. Let's write the condensed from that. So the first group is a CH3. Then we have a CH with our chlorine bonded off of that. Another CH with our hydroxyl group. Then a CH2, and finally a CH3 group. So that is how to draw 2-chloro-3-pentanol. Naming phenols. Now, the simplest phenol on the left is simply named as phenol. The other ones, when they have substituents, they are going to be named with the base name of phenol, and then we will name the substituents as prefixes. Now, because that hydroxyl group in phenol is coming off of our benzene ring, that carbon in your benzene ring is always going to be carbon number 1. And then you can number it either clockwise or counterclockwise, whichever way gives the lowest set of numbers for naming them. And so in this case, carbon number 2, and you have a methyl group off of it. So that would simply be 2-methyl phenol. So fairly straightforward and what we've seen before. Okay, this last one, again, the carbon number 1 is the one that is bonding to the hydroxyl group. And in this case, I'm going to start numbering counterclockwise to give the lowest set of numbers possible. And I can stop numbering there. So we have off of the 2nd carbon a methyl group, and off of the 4th carbon a methyl group. So this one would be 2,4-dimethyl. Oh, there's my L. Phenol. So that is how to name phenols. The last thing that we're going to look at is how to draw a phenol, and we're going to draw 2,6-dichlorophenol. So just start with drawing a phenol, which is a benzene ring, your hydroxyl group. If that is carbon number 1 at the top, then I'll just number so we can know where to stick our substituents. So off of carbon number 2, I'm just going to draw a chlorine. And then off of carbon number 6 over here, I will draw a chlorine. And that is 2,6-dichlorophenol. So this goes through just highlights how to name and draw alcohols and phenols. And you can see from this that it's really based off of what you have learned for alkanes already.